In this video, we will look at standard scores. We sometimes say it's like comparing apples and oranges to mean we can't compare two things. With statistics, however, we can compare things that seem incomparable to some degree. Suppose a student scored 90 on a music test and 45 on an English test. Direct comparison of these scores could be difficult because the exams may not be equivalent in terms of number of questions, value of each question, and so forth. A comparison of a relative standard similar to both can be made. This comparison uses the mean and standard deviation. A z-score, or standard score, for a value is obtained by subtracting the mean from the value and dividing the result by the standard deviation. The symbol for the standard score is z. So z equals the value minus the mean divided by the standard deviation. For samples, the formula is z equals x minus x bar over s. And for populations, the formula is z equals x minus mu over sigma. The z-score represents the number of standard deviations that a data value falls above or below the mean. As an example, we'll look at test scores. A student scored 85 on an English test, while the mean score of all the students was 76 and the standard deviation was 4. She also scored 42 on a French test, where the mean was 36 and the standard deviation was 3. Compare the relative positions on the two tests. Solution. First, find the z-scores. For the English exam, that's z equals x minus x bar over s, which is equal to 85 minus 76 over 4, which is 2.25. For the French test, z is 42 minus 36 over 3, which is 2. Since the z-score for the English test is higher than the z-score for the French test, her relative position in the English class is higher than her relative position in the French class. If the z-score is positive, the score is above the mean. If the z-score is 0, the score is the same as the mean. If the z-score is negative, the score is below the mean. Example, marriage ages. In a recent study, the mean age at which men get married is said to be 26.4 years, with a standard deviation of 2 years. The mean age at which women marry is 23.5 years, with a standard deviation of 2.3 years. Find the relative positions for a man who marries at age 24 and a woman who marries at age 22. We calculate the z-scores for each. For the man, the z-score is negative 1.2, and for the woman, the z-score is negative 0.65. In this case, the woman's age at marriage is relatively higher than the man's age at marriage. When all data available for a variable are transformed into z-scores, the mean will be 0 and the standard deviation will be 1.